Hello everyone. In this video, we'll see a competitive programming problem. This is a very simple problem. You have to find the number of islands in a matrix. The island is denoted by a number 1, and the M0 is literally like a ocean. So this is one island. This group of ones, you have to check in all of the 8 directions, and you have to find out how many number of islands in this matrix. For example, here this group of 1 stands for one island, and this is one island, and here one island, and these four all ones together are one island. So 1, 2, 3, 4. There are 4 islands are there. So the answer is 4. We have to print 4. And in the next one, in this example, you can see these all zeros are, it's like ocean, and these ones are like land. So this is island. These 3 ones are island, and here this group of ones are one island. So the answer is 2. So how do we write a C++ program for this? We'll go to our IDE, and I'm checking my compiler, is it working or not. Yeah, hello world gets printed. So what the user input is, like, you'll have a row and column, number of rows and number of columns, and you'll get one line of numbers. Those many rows of numbers you'll get, so you have to read those numbers and place it in the array, and you have to find out the answer. For example, here the answer is 2. Here you have see the sequence of 1, and here 1. So the answer, what it should print is 2. And here this 1, 2, 3, and 4. Output should be 4. Okay, first we'll read these numbers. So row and column, and then the array. I'm removing this one. Before proceeding, we have to define the row and column because we have to use it across our functions. So I'm using hash define row as some 1000 or 100, and then hash define column, and this also to 100. And int main, I'm declaring the int as r and c, row and column, and the result as count. I'm initializing that count as 0, and then c in r and c in c, and then I have to read that array. Before that, I make sure I declare that array. Here int arr, here I'm giving us 100 and 100 cross 100 matrix. Here you have to give row, and here the same for loop for column j and c. Now you have to read that number in this array. So c in arr of I and arr of j. Arr of I and j. Now this algorithm is you're going to implement in this one is DFS searching. What you have to do for finding out the solution for this. So the literal algorithm is you have to go through each and every cell in this one. When you have one only, you have to check whether that continuity is there or not. When a 0 is there, you don't need to check that cell at all. You can just skip it. So what I'm doing is I have to recursively call. So how do I'm doing is for same thing int for r and C. As stated before, we have to call when it is equal to 1. So ing, here you have to call this function. So I'm declaring void dfs. Here I'm making this call dfs. If you don't know what is dfs or recursive function, you can go and go through other videos from our channel. I'll give link for those. So this is a very simple algorithm for DFS. DFS means the depth first search. Here literally you are going each and every single direction when one cell is taken. So how do I write the algorithm for this? Here I'm picking this first number. I have to check all the directions. Direction is meant for neighboring cells. For example, when I take this first number, these are the neighboring cells. When I'm taking this one, 1, 2, 3, 4, 5, 6, 7, and 8. There are at most there can be 8 neighbor cells are there. So I have to find out all those neighboring cells and check whether that one is there or not. For example, here you have one. Here in top direction only you have the one. So you have to continue on the top direction. So I'm picking this one and I'm going up, it's there. So going up, it's there. Going up, it's there. Going up, it's there. So here in this direction and all, I no need to go because there is 0. So these all together we can conclude it as one island. When it comes to here, I don't have any other cells having the one value, so I'll conclude this one itself as a one island. So one more island. Here when I'm coming across this line, here I have one. Here when moving to the right side, I have one cell. When others direction and all, I don't have one. So here I have. When you're encountering this one, you no need to go back again to this cell. So we have to once we visited this cell, we have to mark it as 0 or any other number, so that you no need to go again in this one. Okay, here one more one. So totally there are 4. So how do we implement that in coding? So we'll use DFS algorithm as told earlier. Depth first search. Here the depth is going to all these 8 directions. So I'll once again we'll come and we'll see how do we see this all 8 directions. So for example, here we don't have other we will have only the 3 directions. It's literally like left, bottom, and bottom, right. So there are 3. When we have here or here, we have top left, and the same row and left. So there are 3 directions. So how do we handle that first? Which means literally here you know this indexer starts from 0, 1, 2, 3, 4. So I have these numbers called R and C. The total number of rows here are 5, and total number of columns is having 5. So I should not exceed these values. So I have to add that condition, and I should not come to less than 0. So -1, -2 and all is not possible. So it should not go beyond 0. So what I'm doing is I'm declaring one function. In that function I must need that array reference. So I'm taking as int arr, and here I declare those row and column, and I need that current row and current column, and I need total number of rows and total number of columns. Here R is the current row and C is the current column, and capital R is total row and capital C is total column. Okay. um I need to first check, is it safe to move the direction. um I'm adding one condition here. If if that row, the current row is less than 0, less than 0 will not be possible. So in that case, or this current row is greater than or equal to the total rows. Here why do I give this equal to, is it start from 0, so we'll exclude the ending number. That case we have to add this equal to, and then column should not go less than 0, and column should not go above the total number of columns. If these are all the cases, I have to end the program. I should not continue in these cases. So I'm returning. This is the condition to break this recursive functions. Here DFS itself is a recursive function. So this is the condition to break. Whenever you are declaring a recursive function, you must give this condition when it should end or when it should not follow the recursion. So if it is not followed, your computer stack will overflow and your machine will crash. And I have to check when it is the array value equals 1. I have to check here whenever it is a 1. I for zeros I no need to check at all. So I'm making it as RNC, and whenever it is 1, I'm continuing the operations. Uh, so in order to avoid this visiting the same cell, when see here I have 1 and I go to the this left direction, and I found out 1 is there. But when I'm checking this again this 1, I should not go the left side and check again this value. So in order to avoid that, I mark this as a 0, so that I'll not come back here again. So ARR of equal to 0. Here ARR. So here the core of our algorithm is, you need to go to 8 different directions. So how you can find out those 8 direction is, I'm just erasing all these. Yeah, I'm picking this cell, and there are 8 direction. We told there is in the top row, there is left, top and right. In the same row, left, right. In bottom row, left, bottom, right. There are 3. So these 3, 3, 6 and plus 2, 8. So 8 lines I have to type. So each different directions I have to go. So the why I'm using a recursion in this one is, I'm going to do the same operation. That's the reason. So here when I'm having 1 here, I'm finding out in the 8 places. When I'm having in 0 also, or some other number also, I'll do the same operations each and every time. So that's the reason I'm going here with recursion. So you need 8 lines literally, because you're traveling in 8 different directions. You can literally like 1, 2, 3, 4, 5, 6, 7, 8. First one is this one. So when I'm having this row R and column C. This position is denoted by the row R and column C. So you know this small letter R stands for the current row and the small letter C stands for the current column. So you have this numbers, and with this numbers reference you can find out the top and bottom, left or right, everything. So how here is, I'm one row above, which means 2 1, it's literally minus 1. Here 3 2, it's literally minus, difference is minus 1. Here 3 and 4, literally difference is minus 1. So in order to reach this cell you have to give R minus 1 and C is there. This is first column, second column, and this is third column, and this is fourth column, this is fifth column. So here also the case is same because it is 3 minus 2, which means C minus 1. You can find this difference will always be minus 1. And the next is, we'll finish up this top row, these three cells and these three cells, and we'll come this. It's not at all a matter which order you pick, even though if you mix up also the answer will be the same. So now this cell is over. Now you have to pick this cell. Here this number is same, the column is same, but you are going one row above, so R minus 1. And here the number 1 is increased, 3 plus 1 will become 4, so the column is increased, so plus 1, but you are in the same above row, so R minus 1. There are 3 cells we have successfully finished. So I'll convert this one to the code. So DFS, I have to pass the same array and R minus 1 comma C, but you have to pass the total row and column as same as what it is. So row minus 1, column minus 1, then column is same, then column plus 1. 3 cells we have finished. Next is in the same row. In the same row, here I just here I'll write the same row R is same because we are standing in the same row. So there are only 2 cells, 1 and 2. This cell we have finished. There are only 2. So I need 2R. Then column is, we are going one column left, for left we have to write C minus 1. So we are going decrementing by number and C plus 1, one column after this number. So I'm writing 2 lines. The row is same, so I don't need a minus 1. So R C minus 1 and R C plus 1. And then will come the bottom row. In the bottom row, you know this difference is 1. So what I'm doing is, I'll erase first. I have to come to this row. So our row is incremented. So R plus 1 and column is reduced. So C minus 1. And the next one, row is increased but the column remains same. And the next one, row is same and column is increased. So C plus 1. So we convert this one to a code. It's literally the same thing. So you can copy. It's plus, plus and plus. So that's over. Here in this example, these first 3 lines for the top row and the middle section is for the same row, and these 3 lines for the below row. Okay, here once those all are ready, you can call this. You have to pass that array and then I comma j and total row and total column. Okay, you may think this, why we are writing this one and why we are writing separately as this one. So I need a repetitive function. That's why I told that I going for recursive functions. I'll 1 minute, I'll clean everything. um, we have this one. So you from first we'll take, we have this one, we call this function, and then we'll go here. But after completing these functions, we have to continue with other cells. So we need reference as go to this one, we have to come like this. And then once this finished, you have to come here, and this have to come here, and this is how the flow goes. We have to go to cell by cell. First we'll go this one, but we have deducted this one with DFS. But when we'll reach this one, so that's the reason we are iterating all of those cells, and we are finding out whether that one is there in the each cell or not. Okay, and we are passing the current row and current column, and we have passing the total number of rows and total number of columns to the DFS. Here the thing you have to do is, here you have to count it, count plus plus. This is the answer. So you have to write cout count indel, and I'm making as count. Okay, our algorithm is ready. I hope you understood this 8 lines and why we write it as 0, because we know we should not visit the same cell again and again. So that's the reason we are giving it as 0. And it's ready to run. I'm going back to my notepad and I'm copying these values. I'm coming back and run the code. I'm copying it. So the answer is 4. It's correct. And then I'm going back and copying again and run the code, and it should print 2. Here we have this all sequence of 1 as one array, one island, and this one is the one more island. Okay, I hope you understood this problem and the solution for this, and it gives the basic introduction of DFS. This is matrix DFS. This is different, and tree DFS are different, and it don't get confused in this. Okay, we'll see in the next video. Thank you for watching.